Hi everyone, this is Fred Briggs, and I wanted to show you how to design your own PCB using EAGLE CAD. We're going to break this into three different parts, and here we're going to start with doing the schematic. The second part is going to be doing the PCB layout itself, and the third part is going to be getting into working a little bit more with the layers, adding text, creating the Gerbers, and getting into how you would actually submit the files into a board house for fabrication. So without further ado, first thing we need to do in order to design our PC board is get the schematics. That's what we're going to start with here. So when getting started with EAGLE CAD, when you get this going, this is going to be the first screen that you see. And we're going to need libraries. Libraries of parts are going to be the resistors, capacitors, microcontrollers, whatever it is you're adding to your boards. Of course, you can create your own, but that can be time consuming and sometimes a little bit complicated. So we like to use known parts. In this case, SparkFun and Adafruit both offer some fantastic libraries with all of the parts they use. That's a great resource. For this class, I've built a library which I'm going to make available on GitHub. I will link to that in the description. You can just load the library, which I will show you how to load libraries in another video, so please look for that. And once you have that, you'll be ready to begin. So to get started, just go to File, New, Schematic, and this will get us going. Alright, so here's our work area. So the first thing we need to do is go to Library, Use. We want to tell it which library to use. In this case, I created a library called class.lbr or library, and that's where I have all of the components I'll be using in today's class. So it's a really simplified library. For today's class, I wanted to do something fun and possibly useful, something that most people have probably worked with, which is an Arduino Uno. So we're actually going to design our very own Arduino Uno. It will be a stripped down version, so it won't have things like an FTDI, and we won't break out all of the pins, since the purpose of this class is not necessarily to show you how to build an Uno, but how to create a schematic, turn that into an actual fabricated board. But we will put enough functionality in there that if you were actually go through this and have the board fabricated, you could put a bootloader on it and actually run it as an Arduino Uno. So now that we have our library installed, we've told to use that library. So the very first thing we need to do is start adding our parts. So we need our resistors, capacitors. An Arduino Uno uses an Atmel 328P chip. And in this case, we're actually going to design this board using all DIP components. That's all through, another word for that is through hole, or so you'll be able to hand solder this very, very easily if you do decide to fabricate it. There's really no difference if you wanted to do this as a surface mount component, and in the library you should be able to find all the parts in surface mount as well if you decided to do that. I would not suggest doing anything smaller than 0603, which is a sizing for the resistors and capacitors. Any smaller than that, and it gets so small that it's really, really difficult to hand solder them. So 0603 is as small as I would really go, and frankly, bigger would be better. So, but for today's class, we're going to stick with all hole through or through hole components. So the first thing we need to do is start adding our components. So we go to Edit, Add, and we go down and look for, I've got lots and lots of libraries for lots and lots of different projects I've worked on, so we're going to look for our class library that we just told it to use. So let's go ahead and add our Atmel 328P, which is the microcontroller, and we'll go ahead and add that to start with. We'll put it right in the middle here. So you can see it highlights the second one. All I did is left click and it adds it. And so there's our first microcontroller component. And if you look at this, and I'll click on this arrow over here to deselect that, you can see that all the different pins on that are broken out. So it has 28 different pins, and every single pin is identified with the port assignment, exactly what it is, if it's a ground or power or analog port, whatever. So let's start adding some of our additional components we're going to need. So the things we're going to need today, other than the microcontroller, we're going to need a crystal, a 16 megahertz crystal, which is typical of the Arduino Uno. The crystal requires a couple of capacitors, anywhere between 18 and 22 PF. So we want to have some header pins on this, so you could easily, use this with a breadboard. We also need access to, say, the FTDI and SPI pins in order to put a bootloader onto this. And if you don't know what all of those things are, that's fine as well. So let's go ahead and add in the rest of our components here. So we're going to add our 5-volt supply. This chip would typically run on 5 volts. It can be run on a little bit more and down to about 1.8 volts. And if you want to know the exact specifications, Atmel has a very comprehensive data sheet that you can take a look at. So there's our 5-volt supply. We're going to add in a ground symbol. And now this lines up pretty well, but let's say this didn't go quite where I wanted. I can actually right click and you see how it rotates. So in this case I like how it was rotated, and I'm just going to put this right near my G and D or ground symbols so that I can run some wires to this in a moment very easily. So I'm putting this in a nice logical place. Let's continue on adding our components here. Let's get our crystal in there. We'd like to have and you notice I clicked on this one and it didn't just come up. Well, so in the crystal there's actually multiple variants of this. You could actually do a surface mount version or a through-hole version. You can see when I click on these two, up top right here, it's showing what it would look like. So those green circles are indicating that it's a hole that goes all the way through the board, and that's what we're looking for. Just to show you the difference, if I click on this one, see how it has red pads. Those would be solder pads, and this would be the surface mount variant of this. And you can see these were parts that I took from the SparkFung library, which I suggested. Again, I would suggest you download the entire SparkFun library. It has a lot of fantastic parts. They're usually accurate and work very well. So it gives some part numbers in here, so you can easily order these parts. So we're going to stick with the through-hole version just to make it easier to solder up if you did choose to actually do this. So I'm actually right-clicking here because I didn't like the way it was oriented. It came out like this, and it'd make for some weird wire runs if I did that. So I right-clicked, turned it 90 degrees, and you can see I'm lining it up with XTL1 and XTL2, or the crystal lines, off of pins 9 and 10. And there's a couple of capacitors that need to go in there, so let's get those added in there as well. So I'm going to use a 22 PF. Again, this one has multiple variants. It has a 0603 part, which again is quite small for hand soldering, but you could do that, or a more typical through-hole application. So we're going to add one here, and then just click again, and then add it right there as well. So let's add in just a couple more things here, and then we can actually start turning this into something. So in order to make so I'm going to add a 0.1 UF or 0.1 microfarad capacitor. Again, you can see it's green hole, so it's through hole, and you can see the variants above it are 0603 or 0402, which is very, very small, very difficult to do by hand. So again, we're going to stick with a through hole. In order to get the Arduino Uno to do an auto reset when you to load the firmware when you put it in, we actually have to run a capacitor on the reset line, and I'll show you how that hooks up in just a minute. Okay, so we've got both of our capacitors on the there. We've got our 0.1 UF up top there. Now we want to add in some header pins, some 0.1 inch headers, so that we can actually plug in things like an FTDI or breadboard with this, right? So I've got actually let's get our resistors in there first. So we do need a resistor which comes off of the reset, and let's get those. Let's collapse these real quick. Okay, so sorry, I just had to make a quick update there on the library. So to add the connectors, again, just open this up. We want to do, these are 0.1 inch connectors, which is a very standard header pin size. So we're going to use a 1x6 like this. And the 6 is going to be for plugging in an FTDI cable, since we're doing a stripped down version of the Atmel 328P chip. Unlike the Uno, which has an FTDI chip built into the board, we're not going to add that for simplicity's sake here today, because we just want to get through doing a basic schematic and then doing the board design. And then just to break out some generic pins, just so we would have something to play with and a little bit more routing to do. Let's go ahead and add in a 14 pin block, and that'll let us break out a bunch of these pins here. So I think we've got the core pieces that we're looking for here in order to start routing this board. So how do you start routing the board? What's the next step now that we have our components? So we want to go over to this one, wire, click on that, and we can start routing these things. So the reset actually gets tied low, so you would click on here, drag it out, and then double click where you want it to end. So I click on the end, and then double click where I want it to end. So we actually need to tie this high. So we're actually going to, we need a 5-volt line on that. So let's just grab our arrow over here, drag this over, and once it's over there, we can then click back on this. And it's asking if we want to join it to the 5-volt power supply, and yes we do. Alright. So the next step for us is let's start connecting up VCC, which in our case is 5 volts, and then a VCC, which is the analog VCC. So let's get those connected. But in our case, so some of these wires can cross, and we may not necessarily want them to touch, so we want to make sure that these are all connected here and verify with the computer, with the software, that that's what we want to do. So let's put in some junctions there. It's good practice that these are all, we want these all connected to our 5-volt line. And let's go back to our wire and continue to do some routing. So coming off the first crystal line, we connect it to there, and then terminate it our crystal. And we left this one a little bit too low. We'll just move that up. And you see it automatically created the junction line there. So let's add it in here. And if we want to verify if it actually touched, we can actually come in here and move this around. You see how it pulls it around? We know for sure that it's actually connected. So the backside of these capacitors need to be connected to ground. So let's run a line here and just double click, and let's leave it hanging off there for a second, and then bring this one in. And we can use the copy function up here. Click copy, ground, bring it over, and we can want to connect it to ground. Yes, we do. Alright, and we'll continue. We'll wire up our actual ground. I could have brought that ground all the way over and connected all of these, but I wanted to show you the copy function there. And again, we can go back and add in our junctions for good practice. So now our microcontroller has power, it has ground, and it's got a 16 megahertz crystal in there. So, but we don't have any way to actually use any of the pins or program it. So let's do that. So we'll want to use this one here as our FTDI line. So since this is going to be our FTDI line, we need to make sure we match the pin out on this so that it matches a standard header pin. We can plug that in. So we're actually going to take power from this, and I've gone ahead and looked up the pin out ahead of time. So the first pin here is going to be a ground line, and so we're going to just do the same thing, copy our ground and connect that right there. Yep. The next line is going to be CTS. The next line is VCC. And the CTS line, we're actually not going to connect that to anything. We're going to just do RX, power, and ground. And so in this situation, we will actually be taking power from the FTDI chip to power power this Arduino. VCC, so we're going to copy our 5-volt line, and again it's oriented the wrong way, so I can just right click, turn that, and connect it. And so that's going to be our input power line. Anything connected to that 5 volts there, once we get to the routing stage on the PCB, these will all be connected. Anything that has ground on it, they will all be connected. So anything with the same name. And I'll show you how to do a little bit more of that in a second. So the next one is TX. And this one will be RX. And the last one is RTS. So running some of these wires, we would have to run these a long ways. So let's take an example here. For example, this one's RTS. We want to use RTS, and I just click, I'll turn, and then I can terminate it there, and so this line is actually what's used to reset the chip every time you're loading new firmware. But that's a really long route, and we might have a bunch of wires going all different ways, especially as we get into this 14-pin block here, and that can turn into a big jumbled mess. So what we're going to do is actually delete this, and let's try and do this just a little bit cleaner. So we're going to pull that out and just leave a little bit of a tab, and then we're going to come into here and use this one which says label. Click on that, and we're going to just label all of these. So click twice, and it's going to leave you with a little $N and a number. So that's now named this line $N$10, $N$11, $N$2, whatever. So we want to go and name these. So let's add RX, TX, and RTS to these. So we can actually type in name up here and then click on each one, and in this case it is TX, and the next one is RX, and the final one is RTS. And then if I do the same thing, let's say up here, add the label, double click, then type in name, or actually type in name at the bar up here, hit enter, and then click on what you want to name, double click, and I'm going to type in RTS, and it should pop up with a something asking if I want to join these. Do I want to connect them? Yes, I do. So now I've created a link between these two, even though I don't have a physical wire. So this is a much neater and easier way. So now, if I want to put some tails onto some of these things, so we definitely know in order to program this thing, we're going to need to have our RX and TX, right? We want to work with that. And in order to get a bootloader into this, we're going to need to have access to the SPI pins here. So we're going to want to break out. We'll use these pins down here, and we'll start with that. So again, let's hit label. Now I'm going to do something a little weird here. So when you're working with serial, you can't have an RX or receive connected to another receive. That'd be two things listening. You can't have TX talking to TX. It'd be two things talking. You need your transmit to be connected to the receive. So I'm actually going to flip this. I want my receive here, RX, to connect to the TX on this side. So I'm actually going to label this TX because I want it connected to this TX line. All right, so even though it looks like I've made a mistake and misnamed this, I haven't because I want these flipped. So the RX is connected to TX, TX, RX. All right. We're going to leave this pin empty, and why don't I just delete that to make sure I haven't made any mistakes there. And then I'm going to run these pins up into our 14 block. Actually, yeah. So just throw some wires here, and since this is a header block used for breadboarding, you can put jumpers in any which way, and we're going to just put these wires, map these wires any which way. Whoops. And if you do get a wire that wasn't quite right, you routed it funny, you can just hit the trash can there and delete it. Alright, so this got a little bit close here, and I don't like how close that is, so I'm actually going to move that. So I'm going to click on the move button, then I'll click on the group button. I'm going to click on this, so I've now highlighted it, and then right click, and then I can scroll down to move group, and we're just going to move that out of the way just a little bit, keep a little bit of spacing to make it a little easier to read some of that stuff. Now let's go in and start putting some labels on some of this stuff. And then again, back to name. It'll just take us a second to go through this. So this was PB0 or port B0. This is PB1, port B1, PB2. Whoops. Alright, so I'm going to go ahead and just finish this up, and we'll be back in 1 second, since I think you get the idea on how to name these. Okay, so I got quite a bit of that routed up. I got, not routed, but connections made on the schematic. So port B0 through B5. So you can see 0, 1, 2, 3, 4, 5 here. I also connected interrupt lines, or PD2 and 3, up here. And just to make it a little bit quicker and simpler, up top here, I'm just going to connect all of these lines directly. And this is really more than we need to be doing just for an intro, but oops. Okay, and again, it's good practice to just come in here, make sure we've terminated all these lines with junctions. Alright, and once you've got that, we have completed our schematic. So the next step, which we're going to go over in the next video, but just to get you started, is to click this button here, and it says Generate, Switch to Board. And do we want to create a board from this schematic? Yes, we do. And now you will see outline of a board along with all of the parts we just generated, and these white lines are all of our parts. So please join me for the next video. We'll go through how to route all of these, create a board from this, and then get it sent out for fabrication. Thanks for listening.